Next, we're going to have Andrew Campbell, who's a senior software engineer at Pachama. They're a technology company harnessing satellite data and AI to empower companies to invest in nature. And Andrew's going to talk a bit about how they've used Fused to improve the product lifecycle at Pachama. So Andrew, without further delay, please excited to hear what you have to share with us today.
Awesome. Thank you, Sean. Can I get a quick thumbs up that screen size is all right? All right, great. Okay, cool. Yeah, so my name's Andrew. I work as a software engineer at Pachama. And as Sean said, Pachama is a company that builds tools and technologies for other companies that are investing in carbon. So I work mostly across our web stack, building tools that are focused around project sourcing, carbon supply availability, project diligence, risk mitigation, and carbon portfolio management. But for the next couple of minutes, I'm going to talk about our land suitability tool. So this is a tool that we've been iterating on for the last several months. It allows users to upload a project boundary on a map and instantly analyze it as being suitable or non-suitable for a reforestation project. And the tool's leveraged Fuse UDFs for on-demand data processing and geospatial visualization within a custom web application. So I will quickly talk about the motivation behind the land suitability tool. Basically, we wanted to build a tool that would help unlock the supply of high quality forestry carbon projects. We deemed there wasn't enough high quality projects to meet the demand of companies looking to invest in carbon offsets. Essentially, we wanted to create a tool that would allow carbon project developers to quickly validate and onboard reforestation projects to Pachama's platform. When we were fleshing out the idea for this tool, there were a few requirements that we knew it needed to satisfy. We're building a platform at Pachama, so we needed this tool to be self-serve in its usage. We needed the tool to be able to process geospatial data on demand specific to where the users are uploading their data. There's not a whole heap of people doing these reforestation projects across the world, so we wanted to cast a really wide net and provide global coverage to capture as much of that input down the funnel that we can. And the data's spatial in its nature. So we wanted a really fast geospatial data visualization, and we needed this tool to be methodology compliant based on established standards. So this is a good time to drop a quick visual of what the tool looks like. Basically, it's a self-serving mapping portal that currently has land suitability and credit projection tooling. So users come in, they can upload or draw boundaries anywhere on the globe. And the results that they get back describe the land that is potentially suitable and unsuitable for a reforestation carbon project. And in all, the tool forms part of the screening stage flow required to onboard a reforestation project onto the Pachama platform. So how it started, we actually got started building this tool before learning about Fused. So our initial approach was modest. We ingested data sets and pre-processed this like binary suitability data set from which we could then take the users' uploads, their boundaries, and extract relevant slices of that binary data in their areas. The tool was originally rolled out to support Brazil, Mexico, and the United States. But as we got rolling, we had some ideas about where we wanted to take it. And we knew that we really wanted to enhance the data offering and functionality of the tool. We had all of these data sets sitting around in the back end that were being used as inputs into this binary result, but we weren't surfacing any of them. And these layers included things like land use, land cover, annual deforestation, annual forest fires, existing canopy cover and slope. And so we had these hypotheses that we wanted to validate, and the Fuse UDF really provided the technical means to test all of these assumptions quickly, economically, and in an iterative manner. So if you're looking at the diagram and the sort of additional component that we tapped onto the tool, we used a UDF to like easily load and process those existing geospatial data sets in their analytical format, which were like cogs and flat geobuffs. And that same UDF returned the data within the user-defined areas as map tiles to the front-end application. So where did we find the benefits in using Fuse for this particular instance? Basically, we could stand up an end-to-end ETL visualization pipeline really quickly. All of the processing and visualization was able to happen in parallel, which sort of ticked that box of having that really speedy, snappy user experience. The UDF allowed us to avoid writing our own APIs and deploying our own modules. And that same UDF code snippet, it could return the data as like visualization tiles or a blob for download, or even summarize statistics based on what the client application was requesting. So yeah, leveraging the Fuse UDF, we basically didn't outlay a large engineering cost on untested product assumptions. So I'll quickly jump into talking through the UDF. So I'm going to be lightning here, but essentially the UDF accepts input parameters that gives context about the project boundary. It goes and extracts land use, land cover information in this particular instance, converts it into vector features to support interactivity on the front end. And then that UDF partitions the data from a cache into smaller payloads based on the UDF's bounding box, resulting in faster map loads. So if I can really quickly jump into, and stop me if I don't have time, but there we go. Quick demo of the tool. Okay, sweet. So here we are, we've got a globe view. This is the land suitability tool. Essentially anywhere on the globe, but because it's my home, I'm going to swing down to a particular area in Australia. The user can draw or drag and drop a boundary onto the map. So this is just sort of a random location. This is firing off some stuff in the back end, of course. It's basically processing that binary eligibility data set. And in the meantime, Fuse is doing its thing and giving us all of the information about these sublayers. And from here, users can sort of jump in. Fuse is loading all of this data into the cache. It's reporting on like summary statistics. And while my internet's trying to stream, and here we go. Great. And then it's supporting these sort of really fast user interactions, which is pretty cool. Users can find out a lot more about their data, sort of determine why some areas are suitable versus unsuitable, play around with interactive layers, and get sort of layer specific information as well. And that's a wrap.
Nice. Thank you so much, Andrew. It's really, really fascinating to see it backing a production application like that, and especially with such nice performant interactions at the UI layer.